All right, law of sines. Okay. Now, if you have a triangle that's not a right triangle, and you know a side and another side and an angle, you can find all the sides and all the angles given just that amount of information. Okay? If you know an angle, another angle, and a side, you can find all the sides in that. Okay? Or if you know an angle, the side in between, and another angle, you can find every side, every angle. Okay? So, this one we're going to talk later about. This is side angle, which is the ambiguous case. So we're not going to worry about that right now. But when you have angle, angle, side, or angle, side, angle, you use what is called the law of sines to figure out all the sides and all the angles. So what is the law of sines? Well, here is the law of sines. The sine of alpha over side A equals the sine of beta over side B. Or the sine of alpha over A equals the sine of gamma over C. Or the sine of beta over B equals the sine of gamma over C. All three of those you'll need to find the sides and the angles. Okay? Does sound easy, doesn't it? Okay. We have a triangle where we know this is 36, this is 57, and this is 14. I want to, if this is A, this is B, and this is C, which means I did that not the greatest. In trigonometry terms, alpha, beta, and gamma. There you go. So this is side A, this is side B, and this is side C. So I want to know what angle gamma is. I want to know what side A is, and I want to know what side B is. The easiest one is find angle gamma. You already know how to find angle gamma. How would we do that?
Add 36 and 57 and subtract it from 180.
Exactly. 36 and 57 add up to 93. 180 minus 93 is 87. So this angle is 87 degrees. Okay? That's just geometry. Find angle or side A, the sine of alpha over A, so we always use opposites. Okay? So we use the sine of my angle, 36, over its opposite side A equals the sine of my angle over its opposite side. Now we can't use 57 in B because we have one of them as an unknown. We have to use what's known. So the sine of 87 over 14. So to solve this, you cross multiply. Take this times this and divide it by this. So we're going to multiply across and divide this direction. So on your calculator, take 14 times the sine of 36, hit equals, and then divide it by the sine of 87. Don't do 14 times the sine of 36 divided by the sine of 87 all in one step, because it'll take 36 times the sine of 87, not the answer times the sine of 87, which will throw you off. Okay? So 14 times the sine of 36, press equals, divided by the sine of 87, press equals, and what do you get? 8.24. Sounds good. Now, to find b, we have 57. So we go the sine of 57 over b equals the sine of what? Should I go 36 over 8.24 or 87 over 14? 87 over 14. Why? Because 8.24 is what type of an answer? A rounded answer, and it could throw your other answer off just slightly. Okay, so you take 14 times the sine of 57, press equals, and divide by the sine of 87, press equals, and what do we get? It's got to be bigger than 8.24.
11.76.
11.76 sounds good to me. Okay, so that's the law of sines. Okay, now not only will you find angle or sides, but you can find angles too. Bless you. So, let's just go into the homework problems. Whoop. So let's go to here. All right. This one is just like the problem I just got done doing. Okay. Let's look at this one. You draw a triangle. If there's not one given to you, you draw a triangle. And you have alpha, beta, and gamma. It doesn't matter where you put alpha and beta and gamma. Gamma is 130.6. Alpha is 13.3. So what does that leave us for beta? How much is left for beta? $36.1. So just throwing out 37 wasn't that bad of a guess. All right. So to find side A, where's A? The bottom, the left, or the right? Bottom, because it's opposite of alpha. Where's B? It's on the right, and C is on the left. So to find A, you go the sine of your angle, 13.3, over its opposite side, A, equals the sine of two things we know. Okay, I know B is 4, so I'm going to put a 4 over here. So the sine of 36.1 over 4. Okay, so if we cross multiply, I take 4 times the sine of 13.3, whatever that is, divided by the sine of 36.1. And what do I get? Should be really small. 1.56. Okay, round to the nearest thousandth. That's to the nearest hundredth. So 1.5, what? 617, so 5.62 to the nearest thousandth. Okay? And then we'd go the sine of 130.6 over c equals a sine of 36.1 over 4. So 4 times the sine of 130.6 divided by the sine of 36.1.
5.155.
Okay? All right. So again, that shouldn't be too much of a problem. Let's look at this next one. A helicopter flies from an airport with a bearing of 21 degrees. After flying for 104 miles, the helicopter flies due east for some time. The helicopter flies back to the airport at a bearing of 230 degrees. How far does the helicopter fly during the final leg of its journey? Now, this is where trig gets a little interesting. Okay? Because of the word bearing, it is not like normal trig. Okay? Normal trig, you start from the x-axis and go degrees counterclockwise around the positive x-axis. Bearing goes from true north. And you go clockwise when you're talking about bearing. So it's different than regular trig. Okay? So, a helicopter flies from the airport with a bearing of 21 degrees. So, if it's flying from true north 21 degrees over, it's going this direction. Okay? Then, after flying 104 miles, it's going to fly due east for a while. Due east is straight to the right. Never eat soggy wheat. Never eat soggy Wheaties. Never eat soggy Wheaties. Waffles? Okay, never eat soggy waffles. All right. So then you go 104 due east for some time. Then it flies back to the airport with a bearing of 230 degrees. So from here, 230 degrees would be where? Well, this is 90, this is 180, so 230 is somewhere over here. Flies back to the airport, 230 degrees. Okay? We want to know how far did it fly on this leg. Okay? So, let's look at this. This is a 21 degree angle right down here. Okay? What's this angle right here? Well, we can use a little geometry to figure that out. If we draw a little crosshair here, if this is 21 degrees here, how many degrees is this right here? 21 degrees, because they're alternate interior angles, right? And if this is a 90 degree angle, because that's straight east and straight south, plane 2 check. Kind of need to pay attention to this. This is 90, this is 21. How many degrees is this? 111 degrees. So this whole angle right here is 111 degrees. Okay? Now, if we know this is 90 and 90, and this whole thing is 230, how far past 90 did I go here? 90 and 90 make 180, plus another 50 makes 230, right? So what's this angle right here? 40 degrees. Okay, so that's 110, that's 40. So this angle down here is whatever's left. 29. 29 and 111 make 140, right? plus another 40 make 180. Okay. Now, I know this side here is 104. I know its opposite angle is 40. So using the law of sines, the sine of 40 over its opposite side, 104, equals, and if we want to find this side, we use its opposite angle, the sine of 111 over x. So the setup is a lot harder than actually doing the math for this problem. The math is pretty easy. 104 times the sine of 111 divided by the sine of 40. And the final answer is? So rounded to the nearest tenth, 151.1 miles. Okay. The next one, the lunar crater problem, which I guarantee you is a test question, probably even a quiz question. So there's a lunar crater on the moon. Okay. Here's point A. We want to measure across it to point B. Okay. Angle BAC, C is somewhere out here. Angle BAC is 111 degrees. Angle BAC is 111 degrees. AC, C is 42 degrees from A. So if we draw a triangle now, it's 42 meters, not 42 degrees. Come on, Mr. Birschbach. That's 111 degrees. This is 42 meters away from A. We want to know the width of the crater, and we know ACB is 41 degrees. So if I know two angles, how many angles do I really know in a triangle? All three. 111 and 41 add up to 152, so how much is left for angle B down there? 28. So I have opposites now. I have the sine of 28 over its opposite side, 42, equals the sine of 41 over its opposite side, x. And then you just cross multiply. Okay? All right. And the last one. So there's a really tall tower. And you know how really tall towers are. They have these wires that go down to hold them upright, right? And some of them have more than one wire on a side. So let's look at this side. Point of the angle of elevation from the top of a tower to the top of the tower from point A on the ground is 12.8 degrees. So here's point A. That's 12.8 degrees. From point B, right here, is 15.3 degrees. From point A to point B is 37.2 meters, or 37.2 feet. We want to know how tall the tower is. That's all we know. Okay? Okay. I'm glad it is easy. All right. So, what we have to do is say, well, if this is 15.3 on this side, what is it on this side? 164.7. And then what's this tiny little angle up here? Going to be awful small. 2.5 degrees. Okay. All right. So the sine of 2.5 degrees over 37.2 should equal the sine of, okay, if I want to find this side y, To find that side, I'd go the sine of 12.8 over y. Okay? So if I get y here, because we know this is going to be a right angle because we want that tower straight up and down. Okay? So if we get y, we can use that to figure out x. So if we cross multiply, 37.2 times the sine of 12.8 divided by the sine of 2.5, how long is y?
188.94.
188.94. Now, if this is a right triangle, we wouldn't have to use the law of sines, but let's just go ahead and do it. The sine of 90 degrees over 188.94 equals the sine of 15.3 degrees over x. So 188.4 times the sine of 15.3 divided by the sine of 90.
$98.86. Or 49. Did I say 49?
49.86 or 49.9. There we go. I was wondering because
I didn't say 49, did I?
no, you didn't.
I didn't say it.
Okay. So that's the basics of what we're doing in our first assignment today. So let us get to work, please.